This question is called Candies in a Jar. And it says you are taking out candies one by one from a jar that has 10 red candies, 20 blue candies, and 30 green candies in it. What is the probability that there are at least one blue candy and one green candy left in the jar when you've taken out all the red candies? When it says what's the probability that there are at least one blue and one green candy left in the jar when you've taken out all the red candies, it's just a fancy way of saying what's the chance you take out all the reds before the rest. Chance that you take out all the red candies before you take out all the blue and the greens. So it's saying like, oh, what's the chance that the order in which you remove the candies is like red, blue, green, or red, green, blue. Right? You're pulling out from a jar. It kind of just wants to know what's the chance that the order in which you remove them is red, blue, green, or red, green, blue. And what's the probability of this happening, right? And since these events are mutually exclusive, which means that they cannot happen at the same time and they're independent. Wait, actually, is that when I think they just can't happen at the same time. And they are independent, I believe. And so that means that we can just break this probability statement that has like a union or statement in between it and break it just into two distinct probability expressions and add them up. So this just becomes probability of red, blue, green, or probability of red, green, blue. Okay, what's the chance that the order in which we remove the candies goes red, all the red first, all the blue first, and then all the green, all the red first, then all the blue, then all the green. So to figure this out, it's hard to go forwards, right? You're trying to say the chance that you go all the red, then all the blue, and all the green. It's kind of hard, but it's easier to imagine this going backwards. What's the chance that this becomes like probability of green being last? It's bad handwriting. Being last, and probability of blue being second last, given green is last. So what's the probability that green is the last candy being taken out? Well, there's 30 green candies in the jar, and any one particular candy has equal probability of being the last candy removed out of 60. That means any candy being removed in particular is 1 out of 60, and there are 30 green candies, and so the chance that the last candy being green is 30 out of 60, right? So this is an and, so you have to multiply them together, times the chance that given green was last, blue is second last. So we had 60 green candies total. We know blue is going to be last, right? So that means between red and blue, what's the chance that from red, the new population of just red and blue is the last. So among red and blue, so like total candies, right, is the denominator. Red and blue, there's 30 candies among them total. What's the chance that blue is the last one of the red and blue batch? Well, there's 20 blue candies against any candy has equal probability of being the last one in a particular population. And so, there's 20 blue and there's 30 population, so there's 20 out of 30 chance that blue is last given green, blue is second last given green was last. And so also this is an or statement, so you add them up, right? Or and plus are the same thing when they're independent events. Okay, and so now again, probability of red, green, blue is probability of blue being last and probability of green being second last given blue is last. So what's the probability of blue being last? out of the 60 candies, the chance that blue is last is 20 out of 60. Now, given blue is last, that means we're dealing with green and red. What's the chance that among the green and red candies, green will be the last one in that population set? Green would be like the last candy being pulled. So any candy has equal probability of being pulled in a particular population set. And so there is between green and red, there's 30 green and 10 red, so there's 40 total. And we're saying the chance that green is last is 30 out of 40. And so we can just cancel. It's a 1/3. We can cancel. It's a 1/4. We said we're adding them up because we're adding up mutually exclusive events, right? An or statement in that case would be just same thing as an addition, right? So now we can just have 1/3 plus 1/4, which equals 7/12. And that's the answer.